Good day everyone, I'm Jude Daniel D. Dumokol, 23 years old, and this is my final project on IS 107. My project title is Spatial Analysis of Aftershock Distribution Relative to the Mainshock. This study explores the spatial behavior of aftershocks following a major earthquake with a focus on their distribution relative to the epicenter of the mainshock. By examining geographic coordinates and analyzing distance patterns, this research reveals key insights into the clustering, spread, and directional trends of aftershocks events. The findings contribute to a deeper understanding of how stress redistribution within the Earth crust influences seismic activity and can aid in assessing seismic risk and hazards in impacted regions. So in plotting demo, first is we will select the replace seismic wave. Still running. So the starting point of the plot is the first recorded earthquake. After that, the following waves represent the succeeding earthquakes. The tall or high waves in the plot indicates the strong earthquake, while the smaller or weaker waves represent the aftershocks occurred after the main event. This visualization helps us to understand the sequence and intensity of seismic activity over time. So on the sidebar, we can adjust the speed of the live seismic wave visualization. So third page is mapping demo. So in the mapping demo, first we will select a province, Surigao del Sur. Then we will select an area, Hinatuan. So the total earthquakes in year 2019 to 2025 is 3,901. Then the strongest magnitude or main shock is 7.4. The aftershocks is 3,900. So this is the earthquake data in year 2019 to 2025. And on the sidebar, there are different visualization layer, hexagon layer, scatter plot layer, province labels, and arc layer. So first is the hexagon layer. First we will start the hexagon layer. So this is the result of hexagon layer. Hexagon layer represents the depth of the earthquakes. The deeper the magnitude, the more intense the hexagon or height. So the red one is the deeper of the earthquakes, then followed by the aftershocks. So the second one is the scatter plot layer. So the scatter plot layer shows the red dots represent the aftershock which are distributed around the main shock location. Then the green the green dots represent the main shock. So as you can see, we didn't see the green one because there's so many aftershock in Surigao del Sur, Hinatuan. So the third is province levels, Hinatuan, province of Surigao del Sur, Hinatuan. The last one is the arc layer. Let's wait for a bit. So this is the result of the arc layer. The arc layer shows connection or jumps between the aftershocks. These arcs help us visualize how the aftershocks are spread out and how they relate to each other, especially. Then the data frame. The fourth page is data frame, spatial analysis of the shock distribution relative to the main shock. So first is we will select province, Surigao del Sur, then select layers 2019. Let's wait for the result. So the CSB data Surigao del Sur year 2019. This is the all data in earthquake or magnitude in year 2019 at Surigao del Sur. Then the blue bar represents aftershock and the red bar represents main shock. This helps let's zoom in. This helps analyze how earthquake strengths are distributed and whether main shock or aftershocks are more frequent at specific magnitudes. Spatial distribution of aftershocks relative to the main shock. So red markers represent main shock locations, blue marker represents aftershock. This this map visualizes the location of earthquake. Red markers represent the location. The size of each marker corresponds to the magnitude of the event. This allows users to see how aftershocks are spatially distributed around the main shock and where the most intense activities are concentrated. Aftershock frequency timeline relative to the main shock. This timeline displays displays how aftershocks occurred over time after a main shock. So the x-axis shows the date and the y-axis shows the magnitude. Each dot represents an aftershock and color represents different provinces. This timeline helps track the temporal sequence of aftershocks, understand how long after the main shock these events continue to happen. So summary of seismic activity by province. Province of Surigao del Sur. Total earthquake in year 2019 is 227. Maximum magnitude in year 2019 is 5.5. Average magnitude 2.6119. And the last is the final page. So the final page in this project, we aim to analyze seismic activity focusing on aftershocks and main shocks. We explore their spatial distribution, temporal sequence, and magnitude to understand The dynamics of seismic events, particularly the relationship between the main shock and the aftershocks that follow. So this is the seismic wave visualization in plotting demo. So I copy the code and merge to the final page. And so the first starting point is the first earthquake. Then the higher the wave, the higher the wave, the highest the magnitude or main shock, and the lower the wave, the lower the aftershock or magnitude. So interactive earthquake mapping. First, we will select a province, Regal del Sur. Then we will select Hinatuan. So in this section, the user can select a province, an area, and the map will display total earthquakes between the year 2019 and year 2025, 3,901, main shock magnitude 7.4, aftershocks 3,900, years covered. So this is the year covered 2019 to 2025. So map layer, earthquake map visualization. So as we can see the sidebar, it displays the following layer, hexagon layer, shows the deep. Let's view it in full screen. So hexagon layer shows the deep earthquake magnitude. This one is the hexagon layer. Then the scatter plot layer distinguishes main shocks, and the green one is the main shock and the red one is the aftershock. So arc layer connects the aftershocks and shows the spatial relationship. So this is the arc layer. Earthquake data analysis. So this is the earthquake data table. Distribution of the shocks and main shocks by magnitude. This chart compares aftershocks and main shocks based on their magnitude. Red bars represent main shocks and blue bars represent aftershocks. The x-axis the x-axis shows the magnitude and the y-axis shows the number of events within that range. Spatial distribution. This this map shows the location. This map shows the location of both main shocks and aftershocks. Red markers indicate the main shock location, while blue markers represent the aftershocks. The size of the marker corresponds to the magnitude of the events. Aftershock timeline. This timeline tracks the occurrence of aftershocks over time, showing their date and magnitude. Green dots indicate main shocks and red dots represent aftershocks. It shows how the aftershocks intensity and frequency evolve following the main shock. So the color violet is year 2019 to year 2025. Summary of seismic activity by province and year. So the province that we select is the Surigao del Sur. Total earthquake in year 2019 to 2025 is 3,901. Maximum magnitude for the main shock 7.4. Average magnitude 2,500 2.5462. And that's all. Thank you.